Determine the largest internal pressure that can be applied to a cylindrical tank. Okay, so let's draw a cylindrical tank like this, and I'll duplicate this. And let me move it around right here, and then we've got our lines. So this is my cylindrical tank. Okay, 1.75 meters outer diameter. So this is 1.75 meters, and the wall thickness is 16 millimeters. Okay. And the ultimate, okay, if the ultimate normal stress, sigma ultimate, is 450 megapascals, and a factor of safety of 5 is desired. Now, let me ask you a question real quick. Is this a thin-walled pressure vessel? Is this a thin-walled pressure vessel? Well, to know, what we would like to do is take the diameter over the thickness and see if that's much greater than 10. So let's see. 1.75 meters divided by 0.016 meters. Well, that's 1.75 divided by 0.016. That's 109. So that checks out. So we can use the formulas that we want. So the first thing is, let's find the allowable stress, which is going to be well, let's write the definition of factor of safety. Factor of safety is sigma ultimate over sigma allowable, or sigma yield over sigma allowable. So sigma allowable is going to be sigma ultimate over the factor of safety. So we have a 5 at the bottom. Sigma ultimate is 450 megapascals. So now 5 fits into 45 9 times. And so we have that the sigma allowable that we want is 90 megapascal. So now, what do we want to find? The largest internal pressure. Well, we're going to have a hoop stress here. We're going to have a hoop stress. And then we're going to have, and I'll change color, we're going to have a longitudinal That's a long word. Okay. And so sigma longitudinal is a half of the sigma hoop. So let's find sigma hoop. Sigma hoop is equal to pressure times the thickness, the radius, divided by the thickness. Now, we want sigma hoop to not be more than 90. So we want 90 equals to PR over T. So let's just solve for P. Sigma hoop times T over r times the thickness divided by the radius. And so what is this? Well, we said we don't want 90 megapascals. And then the thickness, they're saying is 16 millimeters. And the radius, we need to find it. So the radius is going to be what? Well, we have 1.75 meters that we can divide by 2. So that's going to be 0.8125 meters, which is equal, if you multiply by 1,000, to 812.5 millimeters. But we're not done, because you have to subtract the thickness. So you want to do, let me fix it this way, minus the thickness, minus 16 millimeters. So to this, you need to subtract 16 millimeters. So minus 16 millimeters, well, that's going to be 800, and then I have to start another 4, 796.5 millimeters. So let me just check I did this math right. 1.75 times 1,000 divided by 2 minus 16. I did not. I don't think I did. Let me just check. 1.75 divided by 2. That's 0.875 minus 16, 0.875. So that's 875 millimeters minus 875 minus 16, 859. Okay, now we have our radius, so now we can put that in here. So we get 90 times 16 divided by 859, which is 1.676 megapascal. And this should be our answer. I hope this was useful, and I'll see you next time.